Hello students, Deepak Pandey this side, and today we are going to discuss a very important section of physical chemistry and very important section for ionic equilibrium. I know that ionic equilibrium is slightly difficult. The concepts of ionic equilibrium are slightly difficult for most of the students who are preparing for NEET examination or JEE examination. In ionic equilibrium, there is a very important concept of buffer solutions. So first of all, we will talk about that what is this buffer. If you have normally used this buffer word in your day-to-day life, or maybe if you have heard about this buffer solution or buffer word in your day-to-day life, what is buffer? Meaning of buffer. Buffer normally means something, some kind of security. Buffer normally means some kind of secure range, like you have kept something so that there is no harm done to you. That is in daily to daily life. Suppose you are going to a shopkeeper for purchasing some articles, right? Now suppose you are shopkeeper, right? You are shopkeeper and someone is coming to purchase some article, right? Now you want to sell your article at 50 rupees. Now you know the nature of the person who is coming towards you, that he or she is going to bargain a lot. So definitely what price you are going to tell him or her? If you want to sell the article at 50 rupees, are you going to tell that the article is priced at 50 rupees? Definitely not. You will be saying that, sir, the article is priced at 80 rupees or 100 rupees or maybe 200 rupees, depending upon the bargaining capacity of the customer. So what you are doing here? You are keeping some kind of margin, and in English this can also be called as a buffer. You are keeping some buffer. So buffer is a kind of margin that we must have so that there is no harm for us, right? That is normal meaning of buffer. So let's consider that what is the meaning of buffer in the context of chemistry, or what is a buffer solution. See, buffer solution is a type of solution which resists change in pH. A solution, if I ask you about the definition, a solution which resists, what is the meaning of resist? I'll explain. Which resists change in pH means this is a solution if you try to change its pH, and I hope all of you understand that how to change the pH of a solution. Either you add some amount of acid or you add some amount of base. So whenever you add a small amount of acid, I will add this point small amount later, don't worry. Whenever you add small amount of acid to a buffer solution, normally what should happen? Normally, if you consider a normal solution, what should happen? If you are adding an acid to a solution, its pH should decrease, right? If you are adding base to a solution, its pH should increase. But what is happening with buffer? If you are adding small amount of acid to a buffer solution, its pH should decrease. Its pH is going to decrease also, but the decrease in pH is not that much as compared to the decrease in pH of a normal solution. Similarly, if you add base to a buffer solution, its pH is going to increase, but this increase is very small, slight increase as compared to the increase in pH when you add base to a general solution, right? So that is why I'm writing this word resist. What is the meaning of resist? Resist means it will be difficult for you to change the pH of a buffer solution. Please do not think that buffer solution have a constant pH. I'm not saying that it is not going to change. It will change, but there will be small changes, comparatively small changes. Fine, let me explain. So suppose I have a buffer solution. I'll explain what is a buffer solution. We'll talk about that. But suppose we have a buffer solution here. We have a buffer solution. We'll discuss this is made up of what kind of components. Now what you're doing? You are adding small amount. Please, it is very important that we are adding small amount of what? Acid. Now acid should decrease the pH. Definitely the pH will decrease. right? Definitely the pH will decrease, but pH decrease will not be that much significant if you consider any normal solution, right? This is some other solution. This is not a buffer solution. This is some normal solution, any solution, right? Any other solution I'm writing. This is any other solution. What you're doing here? You're adding again small amount of acid. So what is happening here? If you are clearly understanding, then you must say that, sir, this is a normal solution. We are adding acid. What is going to happen to the pH of this solution? There will be a decrease in pH. Please understand, whenever I'm marking, I'm making this kind of arrow means decrease. Bigger arrow means more decrease. Smaller arrow means less decrease. Now what is going to happen to this buffer solution? Its pH will also decrease, but the decrease will be comparatively very, very small as compared to a normal solution. This is the basic fundamental of a buffer. Similarly, what you are going to add, suppose this is a buffer solution. This is a buffer solution and you are adding buffer solution, and what you are adding here? You are adding small amount of base, right? Of course, small amount of base, not too much base. We'll discuss about that also. So what is going to happen if you are going to add small amount of base to a normal solution? Let's say any solution means any general solution, right? You are adding small amount of base. So comparatively, the increase in pH, and why the pH will increase here? Because we are adding base. The increase in pH in this case will be will be significantly larger, while the increase in pH in this case will be only a small change, will only be a small increase. So are you getting my point? What is the meaning of buffer solution? That is why I'm writing resist change in pH. Or if you allow me to write more detailed definition of a buffer solution, means a buffer solution is that solution which resists change in pH when, let us complete this, when small amount of strong acids or strong bases are added. Are you getting this? Right? So what I have mentioned here, small amount. Why, sir, is this important, that small amount? Yes, definitely it is important. Why? Because whenever you are adding large amount of acid, if you are adding, suppose, large amount of acid, 1 glass of acid I am adding to 1 glass of buffer solution, then what is going to happen? Then definitely there will be a large change in pH. So whenever we say buffer solution do not allow large changes in pH if small amount of acids are added as compared to normal solution. In normal solution, even if you add small amount of acid, there will be large change in pH. While in buffer solution, if you add small amount of acid, there will be significantly, slight changes only, which are very much smaller as compared to these changes, right? One more thing you may think about, that, sir, why you are adding strong acid? The thing is, if you are adding weak acid to a buffer solution, it is, in any case, it is not going to have a significant change in pH. If you are adding weak acid will not cause significant change in pH in any case. So that is why I am not discussing about weak acids here. Weak acids are weak acid. They do not provide a large amount of H plus or large amount of OH minus in case of weak bases. So anyhow, they are not going to change pH, whether it is a buffer solution or not a buffer solution. That is why we are talking about strong acid and strong bases. I hope I have made myself very clear about the definition of buffer, right? Now, if we talk about that, sir, how this works, how this happens, that you are adding acid to a solution and the pH is not changing, and you are adding base to a solution and the pH is not changing. Please note, whenever I am saying that the pH is not changing, I mean to say the change is very small, the change is insignificant, right? Let us talk about a first type of buffer. If we discuss, let's say, I'm writing here that the buffer solution are of the following type. Buffer solutions are of the following type. What are the types of buffer solution? One buffer solution is called simple buffer. Simple buffer solution, right? And the other type of buffer solutions are called mixed buffer solution. Mixed buffer solution. The mixed buffer solution, I'll explain them, don't worry. The mixed buffer solution is further categorized. It is further categorized as what? It is further categorized as acidic buffer, and basic buffer. Fine. So first of all, you must be clear about the classification of the types of buffer. So buffer solution consists of simple buffer solution, mixed buffer solution, and the mixed is further categorized as acidic buffer and basic buffer. Now, why they are called as simple buffer and why this one is called as mixed buffer? So let me explain that what simple buffer is made up of. See, if you see simple buffer, it is a solution. First of all, it is a solution. Yes, it is solution. Sir, what kind of solution? Aqueous solution. If nothing is mentioned, simple buffer, aqueous solution. Aqueous solution of what? Aqueous solution of acid, aqueous solution of base, aqueous solution of salt. What? Let's see. Simple buffer is aqueous solution of a salt, aqueous solution of a salt. First of all, simple buffer is the aqueous solution of a salt, right? Now you must have heard that salts are of various types. If you consider the types of salt based on the types of acids and bases, you must recall that there are 4 types of salt. Salt made up of strong acid, strong bases, right? Then salt made up of strong acid, weak bases, weak acid, strong bases, and weak acid, weak bases. There are 4 types of salt based on this category, right? Now, simple buffer is an aqueous solution of salt of weak acid and weak base. Can you think about some examples of salt of weak acid and weak base? The most common weak acid, most of the time you are hearing about this particular weak acid, and that is nothing but the acetic acid. So if you consider a salt made up of acetic acid, which is the anion, which is the acetate anion, and a weak base, let's say NH4OH. So what is the salt? CH3COO NH4 solution. See, this is a salt of weak acid and weak base. If you dissolve this and make a solution, this will be called as a simple buffer solution. Why simple buffer? Because it is made up of only one component, and that is salt. So this is simple buffer. We'll understand the working, but let me give you some more example. Can you think of one more salt which is made up of weak acid and weak base? Let us talk about NH4CN. What do you think? What is the base here? NH4OH. What is the acid here? HCN. Weak base, weak acid. Yes sir, this is also salt of weak acid, weak base. The solution of this salt, either, not both of them, one of them, at a time only one salt of weak acid and weak base. So either a solution of CH3COOH or a solution of NH4CN. Fine. If you make a solution of this salts in water, they are going to act as a simple buffer solution. You can think about other salts also. Weak acid, weak base. So weak base, you can think about copper hydroxide or zinc hydroxide. So let's suppose zinc, and weak acid, carbonic acid. So the salt will be zinc carbonate solution. So all these are example of simple buffer solution. So no need to memorize them. You have to frame salts using weak acid and weak base. You have to think of salts which are made up of weak acid and weak base. Right? No need to memorize all of them. But of course, the first example you should give for a simple buffer is this CH3CONH4, because all of you know the most commonly used weak acid is acetic acid. The most commonly heard, not used, I'm not saying used, but the most commonly, most of the time, which base you are hearing about? You are hearing about NH4OH. Which acid? Weak acid, CH3COH, right? So zinc carbonate, NH4CN, CH3CO, NH4, like that. So these are classified as simple buffer solution. Now you will be thinking, sir, how they are going to manage if you are adding acid from outside? How the pH is not changing that much? If you are adding base from outside, how the pH is not changing that much? How it is possible? How this solution is resisting the change in pH? So let me explain, and that is called buffer action. That is called buffer action. So we'll call this as buffer action of simple buffer. buffer action of simple buffer. Before understanding the buffer action, one point I would like to make sure that all of you must understand this point. Why a solution, pH of a solution changes? What do you think? A solution will become acidic when concentration of H plus is very high, right? A solution will become basic when concentration of OH minus is comparatively higher, like very high means it is comparatively higher. But please note that if a solution is acidic, the free H plus is causing the solution to be acidic. For a solution to be acidic, there must be free H plus ion roaming around in the solution. If the H plus ion is bounded with some other some other kind of anion or some other species, if H plus is attached with something, it is not able to dissociate. It means that H plus will not be causing any change in pH. Fine. Similarly, OH minus can increase the pH of solution only if the OH minus is freely roaming here and there. If OH minus is not freely available, then it cannot change pH. This is the important concept to understand the buffer action. You may think that, sir, okay, this is acid, this acid has H plus, it will decrease the pH, it will increase the acidity. But if that H plus is not able to dissociate from the molecule, then it will not be able to change the pH, right? That is the most important thing, and that you must have this thing in your mind. Acidic solution is having low pH because of the free H plus ion which is available. So the free H plus and free OH minus can only change the pH. Let me explain now what happens here. See, this is a solution and this is a simple buffer solution. Let us assume that this simple buffer solution is made up of CH3 COO NH4 solution. Fine. Now I hope you know that all salts are strong electrolyte. If nothing is mentioned in the question, you can assume that all the salt, whether it is made up of strong acid, strong base, weak acid, strong base, whatever be the type, what we can say that all the salts are strong electrolyte. They are completely dissociated in the solution. The ions which are present here, can you tell me which ions will be present here? You will say that, sir, if this is a salt, then definitely this will dissociate. This salt is going to dissociate, right? And it is a strong electrolyte. Please note that this is a strong electrolyte. So mostly this reaction will be taking place in forward direction. Fine. So I'm writing here this CH3COONH4 is equal to CH3COO minus, what is this? Acetate ion plus NH4 plus. Why, sir, single arrow? Why not double arrow like this? See, all the reactions are reversible up to some extent, right? But those reactions which are more favorable in forward direction, we consider that they are irreversible. And salt is a very, very strong electrolyte. Because it is a strong electrolyte, so it will dissociate completely and the reaction will be more favored in which direction? Forward direction. More favored in which direction? Forward direction, and therefore I am using single arrow. Are you, first of all, you must understand that what are the ions present in the solution. Okay, some of you might think that, sir, you are forgetting there is also H plus ions because this is a solution in water. Yes, there are H plus ion, there are OH minus ion, but you know water is neutral, right? And the concentration of H plus, concentration of OH minus which are provided by water is very, very low, 10 to the power minus 7 mole per liter. So let's not consider H plus and OH minus ions from water, right? Now this solution of salt must be having some pH, right? What is the pH of this solution? If you understand, if you recall the formula of salt hydrolysis, you must know that if this is a buffer, if I ask you that, sir, what is the pH of this solution? You'll say that, sir, pH of this solution, weak acid, weak base. What is the formula to calculate pH? 7 plus half pKa plus pKb. I hope you know this formula, right? This is the pH calculation of this buffer solution. Let's not discuss about the formula right now. We are going to understand that how it works. First of all, let us say that we are adding some amount of acid. Okay, first of all, first point, let us add small amount of strong acid. I'm adding, not weak acids, right? So which is the strong acid? Which strong acid we are adding? Let us add small amount of HCl. Please note, it is very important, that to understand the buffer action, we will be assuming that we are adding small amount of acid. If we add large amount of acid, no buffer action will be there. Definitely there will be large changes in pH, right? So let us add very small amount of acid, HCl. Now what this acid is going to do in this solution? In this solution, this is an acid, H plus. Suppose if this H plus enters the solution and it is freely roaming here and there, so definitely it will decrease the pH by large extent. HCl is very strong acid. If it is roaming freely, it will definitely decrease the pH. Are you getting this? It will definitely decrease the pH. But what is going to happen here? See, the H plus which is going inside, HCl is a strong acid. It is going into the solution. Acid will look for a base. It is going into the solution and acid will look for a base. What is the base here? You are going to say that, sir, this is a salt. Where is the base? What about acetate ion? You must know that weak acid, acetic acid is a very weak acid. So acetate ion will be a strong conjugate base, and therefore inside this solution, this acetate ion is a strong base. Conjugate base is a base, right? So whenever you are adding acid, this acid is going to look for a base. Acid will look for a base, and therefore the acid added from outside will react with what? It will react with CH3COO minus. Please note, if you are going to learn or memorize this, that acid will react with acetate ion, most of the time you are going to forget all those concepts, right? Just remember like this: acid will look for a base. Now HCl added from outside is very small, so this is definitely the limiting reactant, and we have large amount of acetate ion, so acetate ion is excess reactant. Now this acid reacts with the acetate ion and it is going to form what? CH3COOH and plus Cl minus. Don't worry about Cl minus. Why, sir? Cl minus is called as spectator ion. Not Cl minus, means those ions which are just present in the solution and they are not causing any change in the pH. We call them spectator ions, right? So what is happening here? The acid which we added provided H plus, but that H plus combined with what? Conjugate base. What is acetate ion? This is a strong conjugate base, and it is very important that they are what they are producing. They are producing this acid. They are producing acetic acid. Now, sir, so what? Acetic acid is also an acid. Yes. So it will decrease the pH. No. Why no, sir? It will not decrease the pH. Why? Because now the acid which is formed, CH3COOH, is a very weak acid. Acid which is formed, CH3COH, is a very weak acid. Are you getting this? Acid formed is a very weak acid, and you know, weak acid almost remain undissociated, and it remains undissociated. Weak acid, all weak electrolytes, not only weak acid, all weak electrolytes remain undissociated. All of you, are you following me? What I am saying here, this point is very important, as I pointed out earlier also, that acid can change pH if only it is giving sufficient amount of H plus, and H plus is free to roam inside the solution. Now what is happening here? You are adding H plus from outside, but that H plus is getting attached with CH3CO minus, and it is forming what? It is forming acetic acid. So what, sir? Now acetic acid is a weak electrolyte. It will not allow H plus to dissociate. Then then sir pH should not change, even this much of pH should not change. No, acetic acid is a weak acid, some little dissociation of H plus will take place, that is why there will be a very small change in pH. This is why, in fact, many students are able to write this reaction. They say that okay sir, acetic acid will be formed, but if you ask them, okay, acetic acid has been formed, now why it is not changing pH? Because acetic acid is a weak acid and it remains undissociated. pH will only change when H plus is free to roam around. So this is the buffer action of a simple buffer when you add acid. I hope I have made this point very clear, that why pH is not changing, because the acid which is formed is not able to dissociate. Now let's do some addition of base. When, second point, when small amount of strong base, what is strong base? NaOH is added to the buffer. Now please keep that figure in your mind, that diagram in your mind. When small amount of NaOH is added, what is going to happen? What is NaOH? Again the same concept. NaOH is a base. NaOH is a base. Base will look for acid. Are you getting this? Base will look for acid. Okay. So NaOH is base. Yes sir. So I have added NaOH. And it is very small quantity. So this is limiting reactant. Now NaOH is going into the solution. Right? NaOH is going into the solution. And it will look for a base. Sir, where is base? Where is base in the solution? We have salt, so ammonium acetate. We have acetate ion, which is a conjugate base. What about ammonium ion? Ammonium hydroxide is a weak base. So ammonium ion is, your ammonia is a weak base. So ammonium ion is a conjugate acid. So NaOH is going to react with NH4 plus, or you can say OH minus is going to react with NH4 plus, same thing, right? And they are going to form, this is present in excess, so they are going to form what? They are going to form NH4OH. And what about Na plus? We are not interested in concentration of Na plus or Cl minus. Even if they are freely roaming in the solution, they are not going to change pH. So nothing to worry about Na plus and Cl minus. Fine. Now NH4OH, what is this? This is again a weak base, and once weak base is formed, this reaction will not go back in the backward direction. Why? Because this is a weak base. It will remain undissociated. It will remain undissociated. Most of the NH4OH will remain undissociated as it is. So it will not allow the OH minus ion which you added from outside. This OH minus ion will remain attached with NH4 plus. It will not allow the OH minus ion to dissociate, and therefore they will not be able to increase the pH. Slightly increase will be there. Slight increase will be there. Right? They will not allow all of the OH minus to freely roam, and therefore it is not going to change the pH. This is how a simple buffer works. If you understand the concept of simple buffer, then only you will be able to understand the concept of acidic buffer. Fine. So one more thing, you must think about one particular case. Okay, let's say, sir, can NaCl solution act as a buffer? Can NaCl solution act as a buffer? Some student may think, yes sir, it can act as a buffer. How? It can act as a buffer. Sir, how? Because when I am adding H plus, that H plus will combine with Cl minus. Sir, pH will not change. When I am adding OH minus, that OH minus will combine with Na plus. Sir, pH will not change. No, the answer is no. Can NaCl solution act as a buffer? Any buffer? No. Answer is clearly no. Why, sir? See, when you are adding HCl from outside, suppose you are adding HCl, fine, from outside, this HCl will react with, we have acid, okay, sorry, we have acid will, we are having H plus and Cl minus, this will look for base, right? So this H plus or this Cl, this H plus is going to react with what? This H plus is going to react with Cl minus. Let's suppose that H plus you are adding from outside, and this H plus is going to react with Cl minus. Even if it reacts with Cl minus, it is going to form what? it is going to form HCl. Now what is HCl? HCl is a very strong acid. It will not remain undissociated. It will again form H plus and Cl minus. Why I'm making this arrow bigger than the above arrow? Because this reaction will be mainly taking place in backward direction and not in forward direction. Right? See, what I'm trying to explain here, that even if you add H plus, that H plus will combine with Cl minus and it will form HCl. But HCl is a very strong electrolyte. What do you think? Can HCl remain undissociated? No. HCl is a very strong electrolyte. It will again give back what? H plus and Cl minus. And if H plus is freely roaming in the solution, it is going to increase the acidic character and hence decrease the pH. Very strong electrolyte. So don't say, sir, electrolyte, okay, NaCl can also act as a buffer. No, NaCl cannot act as a buffer. So I hope I have made this point very clear. All of you, please understand this point as clearly as you can, because it will help you to understand that what is acidic buffer. So let us now proceed to the next topic, which is what is an acidic buffer. So first of all, what is an acidic buffer? How to identify an acidic buffer, and why we are calling this as mixed buffer? As I told you that earlier, it was a simple buffer. Why acidic buffer is a mixed buffer? See, acidic buffer is a solution. First of all, it is a solution. All the buffer solution, they are solution. Solution of what? Weak acid. It is very important that I must have weak acid, right? Weak acid. Acidic buffer is a solution of weak acid. Water is there, definitely water is there. Solution hai, water will be there, right? Acidic buffer is a solution of weak acid and its salt. What is the meaning of its salt? Its salt means salt of the acid. First of all, you learn this much. Acidic buffer is a solution of weak acid and its salt. Weak acid and its salt. First of all, this much part must be learned, and that is why we are calling it as a mixed buffer. Why mixed buffer? Are you getting my point? Mixed buffer because there are two substances. You will say, sir, in simple buffer also there were two substances. No, there was only one substance, salt. Here we are having two substances, acid, salt. Now let me complete this. Solution of weak acid and its salt with a strong base. Solution of weak acid and its salt with a strong base. This will constitute of an acidic buffer. So don't try to learn the entire line at once. First of all, you convince yourself that mixed buffer consists of two things. Acidic buffer is having weak acid and its salt. Now what kind of salt? Salt of the same acid with a strong base. Let me give you some example. First of all, to give any example of acidic buffer, think about a weak acid. What is weak acid? Again, CH3COH. Is this a weak acid? Yes. So you take water, dissolve some acetic acid in that water and salt of the same acid with a strong base. So that can be sodium acetate or potassium acetate, like that. So this solution in water will behave as an acidic buffer. Please note that this is a weak acid and this one, acetate, is a salt with strong base. Why is there strong base? Because we are having NaOH with us. NaOH and acetic acid salt is there. Any other example if you can think about? What is weak acid? H2CO3, right? H2CO3 is a weak acid, right? And is salt with a strong base. So what is that salt? Na2CO3 is a salt with a strong base. Fine. Weak acid, boric acid is a very weak acid, boric acid, and its salt is also called borax. So the very common example and very important example also, boric acid plus borax can act as acidic buffer. Fine. Any other weak acid you can think about? HCN. HCN is a weak acid. Yes, HCN is a weak acid. Is salt with a strong base? KCN. Fine. You know that most of the acids except HCl, H2SO4, HNO3, HClO4, HBr, HI, most of them are weak acid. Most of the organic acids, they are weak acids. So you can think about any organic acid. Suppose benzoic acid. So benzoic acid is a weak acid. Yes, benzoic acid is a weak acid. Fine. and salt of the benzoic acid with strong base. So that is sodium benzoate. That is sodium benzoate. So sodium benzoic acid plus sodium benzoate. Again an example of acidic buffer. Fine. Now sometimes when we try to find acidic buffer, can you tell me that whether this solution which I'm going to write here, whether this solution is going to act as an acidic buffer or not? Let's say we are having acetic acid. We are having acetic acid and NaOH mixture. Fine. Mixture. The question is whether it can act as buffer or not. Now if you go by the definition, you will say that, sir, you just told us that acidic buffer should contain a weak acid. Yes, so there is a weak acid. Fine. And then it should contain a salt. So where is the salt? So in the very first look, you may think that this is not an acidic buffer. But please note, this is an acid. Acetic acid is a weak acid. What about NaOH? This is a base. Strong base, very strong base. So definitely acid and base are going to react, right? When acid and base are going to react, there will be two cases. There will be two cases, right? First one, NaOH is limiting reactant. Suppose if NaOH is limiting reactant, right? So what do you think? If NaOH is limiting reactant, so at the end of reaction, we will be having, if NaOH is limiting reactant, it will be consumed completely. At the end of the reaction, some acid will be left. So CH3COH will be present and some salt will be formed because these two are going to react. So CH3COONA. What is this? This is a buffer solution. So if the question asks that can they form buffer solution? Yes, they can form buffer solution. This is an acidic buffer. Of course, this is acidic buffer. But there is another scenario. Suppose NaOH is excess reactant and CH3COOH is limiting reactant. Now, what is going to happen in this case? If acetic acid is limiting reactant, it will be entirely consumed by the base which is present in excess. So, at the end of reaction, we'll be having base, okay, base will be left and some salt. So is this an acidic buffer? No, sir. So then it will be basic buffer? No, that is different. So this is not a buffer. Fine. So when we have this kind of option, when there is a acid plus base, so first of all try to make them react. First of all complete the reaction and think about it that if acid is limiting, then at last acid will not be present. So definitely it cannot be a buffer. If base is limiting, then at the end of reaction acid will be remaining and there will be some amount of salt present and hence it can act as buffer. So this kind of question is also given, whether they can act as buffer or not. And if you solve them, if you just solve the question in hurry, definitely you may think that, sir, this will not act as buffer, but this can act as buffer. Are you getting this? Okay, I'll also try to explain the buffer action of this acidic buffer. We will not derive the results today. We will not derive the numerical problem results, the calculation of pH of acidic buffer. But let me explain this, how the acidic buffer is going to work. So first of all, we'll write down here buffer action. Now this is the buffer action of acidic buffer. This is the buffer action of acidic buffer. Fine. How it works? So first of all, think about an acidic buffer. So let's suppose we have a solution of weak acid. So CH3COO, simplest acidic buffer I am assuming. Please note this is a weak acid, so this is weak electrolyte and therefore I am using this reversible sign. And its dissociation is almost negligible. You can neglect. Obviously it is dissociating, but the dissociation is very low, very less amount of acetate ion and H plus are given by a weak electrolyte like acetic acid. The value of Ka of acetic acid is about 10 raised to the power minus 5, right? And therefore the dissociation of acetic acid is hardly 2% to 3%. So you can assume that this acetate ion and H plus ion given by the acetic acid, you can assume that they are not present there. right? They're not, the acetate ion given by the acetic acid is almost negligible. Fine, first point. Which other component is there? Salt. Salt of acetic acid with a strong base, CH3CONA. Because this is salt, I'm making a single arrow, right? Arrows are not very important, but if you try to understand them conceptually, then you know that there is meaning of each and everything. If I'm making a single arrow, then I'm assuming that it is a strong electrolyte. Salts are strong electrolyte. So it will be giving acetate ion, CH3COO minus and Na plus. So first of all, you must be sure, you must know that which ions are present in this solution. Fine. Now, to explain buffer action, again the same thing. Sir, let's do one thing. First, let's add small amount, very small. There is no number given to small amount. Small amount means comparatively small amount as compared to the buffer, right? So let's add small amount of HCl. Fine. Now this HCl is acid. Again, if it is acid, it will look for base. If it is acid, it will look for base. What is the base here? Is there any base? This is acid, salt. This is the conjugate base. This is the conjugate base. Definitely, the conjugate base is present in the solution in large amount. The conjugate base is acetate ion, so acid HCl is going to react with the conjugate base. And please note one thing: conjugate base is present in large amount, but most of the conjugate base is coming from where? Is it coming from the acid? No, because acid is a weak electrolyte. So most of the conjugate base, it is coming from the salt. This is a very, very important assumption which will be used in deriving the pH expression of acidic buffer. Fine. So most of the acetate ion which I am using here, assuming it is mostly coming from salt, right? Why? Because acid is a weak acid. Not this one. This acid is a weak acid, right? So they are going to form what? They are going to form CH3COOH. Again the same concept which I used earlier. CH3COH plus Cl minus. Not interested in Cl minus. Now what is this? Sir, it will form a weak acid, and this weak acid will remain undissociated. And if this weak acid is undissociated, it means the H plus is not freely roaming inside the system. And if H plus is not freely roaming, it means that the pH will not change. Are you getting my point? If you have understood the concept, think about that what is going to happen when I am adding here a base. What is going to happen when I am adding base? Consider a strong base. Think about it for 1 minute. Base, it will look for an acid. So let us add some base. Let's add small amount of base. Let's add small amount of base. Fine. What is base? NaOH, strong base. NaOH is going into the solution and it is trying to change the pH. You are trying to change the pH of a buffer solution. I am adding NaOH. It will produce OH minus ion and it will increase the pH of solution. But NaOH is a base. And which component is present here? Sir, acid. Base will look for an acid, right? So NaOH is base and base will look for an acid. Acid will look for an base, a base, and base will look for an acid. Where is the acid? Sir, acid is not dissociated. Then how it is going to react? Please note that acid, even if it is not dissociated, if it is undissociated, still it will react with base. Some of my students, sometimes they ask that, sir, you just said that acid is feebly dissociated, very less dissociated, then how it is going to react with base? Please note that reacting with base and acid, reaction of base and acid, it is not necessary. The base can also react with undissociated acid. So NaOH will react with CH3COOH, and what it is going to form, please see. It is going to form CH3COO Na and plus water. Sir, but this is not a weak electrolyte. Yes, it is strong electrolyte, but is it producing H plus? Is it producing OH minus? No. And what is this? Water. Water. Can it change pH? No, sir. It is almost neutral. What is neutral? In fact, not almost neutral. What about this? Is it producing H? This is a strong electrolyte. Yes. It will dissociate. Yes. But is it producing water? Sorry, is it producing H plus? No. Is it producing OH minus? No. Then how it is going to change pH? But yes, you must have heard about salt hydrolysis. There will be some hydrolysis of this salt, due to which a slight change in pH will be there, right? So that is why in both the cases, this is neutral and this salt will cause slight change in pH. Slight change in pH. Because of what? Because of salt hydrolysis. So you must know the reason of each and every point. So what we have concluded here? We have concluded that in acidic buffer also, neither HCl nor NaOH was able to change the pH of the buffer solution to a large extent. That is how a buffer works. And if you have understood the concept of simple buffer working, then you will also clearly understand the concept of acidic buffer working. Right? Now, I will give you one point to think. If you can explain yourself that, sir, will this buffer work if only acid is present? Think about it. Or will this buffer work if only base is present? Think about it. If you can explain yourself, I am giving an answer that if only acid is present here or only salt is present here, then this buffer will not work. It may, like suppose, if acid is present in the buffer, salt is not present, it is possible that you can control the pH when base is added from outside, but you will not be able to control the pH when acid is added from outside. So, I mean, you should be able to explain yourself that, sir, why there are two components present here. Earlier, there was only one component and it was able to resist the change in pH when acid was added as well as when base was added. Why there is a requirement of two components here? If you can explain yourself this particular point, it means that you have understood the concept of buffer and buffer action very clearly. So that's all for today's class. We'll be discussing about action, buffer action of basic buffer, and we will be discussing about the pH formulas of acidic and basic buffer. Thank you.